Today I'll be talking to you about satellites and specifically a few main examples, such as Elon Musk's Starlink satellites, the International Space Station, and NASA's TDRS satellites. So, before we get started, I'll just tell you a little bit more about myself. So, my name is Eamon Miyazi. I'm 17 years old and I live in Australia, though I originally came from Bangladesh. I want to become an aerospace engineer when I grow up because this field just really interests me, especially the aspect of constructing vehicles that go to space. I also want to communicate information about space and science to anyone curious. So I've started writing about space concepts and news to help reach these goals. These can be accessed at this link here, which should be in the chat. Okay. Oops. So, to begin, what are satellites? There are two main classes of satellites: natural satellites and artificial satellites. Natural satellites just like satellites which exist in nature and aren't made by humans. This is really anything that orbits another object. So the Earth is a natural satellite of the Sun, and the Moon is a natural satellite of the Earth. Artificial satellites, on the other hand, are created by humans and usually serve some kind of purpose for communications, weather, or anything else really. Today I'll be talking about artificial satellites, and specifically three main examples, which are Starlink, the International Space Station, and NASA's TDRS constellation. Now, a little bit about the history of satellites. The first satellite was launched in 1957. This was Sputnik by the Soviet Union, and since then there has been over 9,000 satellites launched by over 40 different countries. And with developments in the commercial space industry, the satellites have been launched more and more frequently. We've been seeing Elon Musk and SpaceX launching hundreds of satellites for the Starlink constellation, which I will talk to you about right now. So, Starlink. Starlink is Elon Musk's first foray into space-based internet, which is basically, normally internet is transmitted through wires, be it copper or fiber optics, usually underground, but space-based internet sends information to satellites in orbit around Earth, which then send it back to you to give you internet. So these satellites are being launched by SpaceX in batches of around 40 to 50. Recently there was a launch where they launched approximately 53, if I remember correctly, which is... So, the Starlink service is available in 30 different countries with over 400,000 subscribers, and they have plans to launch the service all around the world. So the first Starlink satellite was launched in 2019, and in just the 3 years since then, there are now over 2,500 of these satellites in low Earth orbit. But what makes Starlink so special? Because, as you may know, there has already been space-based internet for many years. Well, Starlink satellites orbit in low Earth orbit, LEO, whereas other systems generally orbit in geostationary orbits, GEO. Low Earth orbits are much closer to the ground, as the name suggests, whereas geostationary orbits are at a high enough altitude that the orbit takes 24 hours, the same length of a day on Earth. But the problem with geostationary orbits is that to send a signal from Earth to the satellite and then send it back down to the receiver, it takes at least half a second. Now, this is very impractical for many purposes, because if you need something to happen very quickly with a quick response time, it's just impossible. In contrast, at LEO, the latency is around 25 to 35 milliseconds, meaning the time it takes to get the signal and send it back is 25 to 35 milliseconds. And this makes it much more comparable to modern fiber optic systems and other internet transfer methods. So this makes Starlink a much more practical way of using space-based internet. It is also relatively affordable and provides high-speed internet that can also function portably, because if you have looked into Starlink before, you may know that they have a Starlink for RVs service where you can attach one of their satellites to your vehicle so you can have access to their internet at all times. But it's not a perfect system. The most problematic part of Starlink is their brightness, because they reflect light from the sun and other sources, and this interrupts with astronomy from the ground. As you can see on this image on the left of the slide, that's a photo from an observatory where the bright lines are the paths of Starlink satellites. As you can see, this would be very problematic to study stars because it effectively just blocks out much of the sky. Even the brightness is so bright that you can see them with the naked eye, which just really shows how serious it is. Now, SpaceX has been making some effort to make them less reflective, but in general it is still an issue that is important for them to resolve. Now, they also contribute to the space junk problem, because these satellites won't function forever, and once they cease to work, they would just be orbiting Earth until they eventually come back down and end up burning up. But this is a problem, as the more space junk there is, the harder it is to launch missions through Earth into space safely and effectively, because there's the risk of a bit of space debris hitting a rocket or the International Space Station, for example, and doing serious damage. So to help with this, the satellites have an ion thruster, which is a form of propulsion which uses electricity instead of a regular chemical fuel, called a krypton Hall effect thruster. And they are also connected to a tracking system so that at all times the position of the satellites are known. And although these don't prevent the risk of them contributing to space junk, it at least makes it easier to help the problem. So now let's talk about the International Space Station. As you all probably know, the International Space Station is a massive structure orbiting Earth, and it is honestly an incredible feat of global cooperation. So the first component of the station was launched in 1998, and from there they brought more and more components up to construct the station as we see it now. And the first long-term resident arrived in early November 2000. And since approximately 2001, there has always been at least one person on the International Space Station. It is, as I said before, one of the greatest feats of international collaboration, as it involved many nations from across the globe, such as the United States, Europe, and Russia, to construct this scientific station. So there are 5 major parties which contributed to the construction of the station, and these are NASA, which is the National Aeronautics and Space Administration in the United States. There is Roscosmos, which is Russia's national space agency. There's JAXA, which is Japan's space agency. Then ESA, which is the European Space Agency. And finally CSA, the Canadian Space Agency. The station is divided into two main sections, which is the Russian section and the American section. But as you may have seen on the news recently, Russia has said that they will cease to cooperate with the International Space Station from 2024. So whilst the exact circumstances of this are not exactly certain, this could become a very problematic issue for the station's future. So, the International Space Station is the largest artificial satellite, and it weighs 450 metric tons, which is nearly a million pounds, US pounds. Now, this is incredibly massive, and yeah, which is why the station had to be launched in separate sections, because it would be impossible to launch the entire station all at once because of the fuel costs and the size. Now, the International Space Station isn't in zero gravity. It orbits at around 90 kilometers up, maybe a little higher, but at this altitude, Earth's gravity is pretty much unchanged. It's pretty much the same 9.8 meters a second squared. But as you can see, people in the International Space Station float. This is a phenomenon known as apparent weightlessness, as the space station and the astronauts are both accelerating at the same rate. It's approximately equivalent to them being completely weightless. Now, the microgravity environment of the space station allows them to do science that would not reasonably be possible on Earth. And this involves research for future missions into deep space, like Mars or the Moon, for example. So some of this research includes growing plants in space, as you might have seen a few months ago, where they grew lettuce and some other vegetables. Then studying the effects on low gravity on Earth, because in the weightless environment, it actually turns out that a human's bone density decreases, and this causes many problems, especially when they return to Earth, as it becomes harder for them to walk or move. So this is also why on the International Space Station, all the astronauts have to do a strict exercise regime, to maintain their muscle mass and their bones. But studying this is important because other planets like Mars and our moon have much lower gravity than here on Earth, so the effects of this must be studied to make sure that astronauts for potential colonies to these places aren't negatively impacted too much. Then they also use the environment to test novel technologies. And they have actually been doing science on the International Space Station for 20 years as of this year, which is pretty incredible. Much of the research is also helping communities down here on Earth, such as with water treatment. And there have been nearly 3,000 experiments conducted in the International Space Station, which is an incredible feat. But despite all this incredible work, the International Space Station will not last forever, because in the early 2030s, NASA and other global partners have scheduled to decommission the station, which means that they will send it on a course back into Earth's atmosphere. It will burn up and crash land, probably somewhere in the ocean. So, because of this, there wouldn't be because currently the only space stations are the International Space Station and more recently China's Tiangong Space Station. So when the International Space Station is decommissioned, then China's station will be the only one in low Earth orbit as far as national space stations go. However, There is a company called Axiom Space, which hopes to build the first commercial space station. As you can see on the image on the left-hand side of the slide there, that's a rendering of what their space station will potentially look like. So, they hope to launch the station first as a module to the International Space Station, and one of the first commercial modules at that, before, once the International Space Station is decommissioned, decoupling it from there and having their own space, having their Axiom Space Station be its own independent station. There will also be other space stations potentially in orbit around the Moon, such as NASA's Lunar Gateway, which will enable easy access to the lunar surface for potential lunar bases. If you want to read more about this, you can look at some blog articles that I've written at the link in the chat. So now we'll move on to TDRS. Now, TDRS stands for Tracking and Data Relay Satellites. These satellites are owned and operated by NASA, and this constellation is a network which orbits in geosynchronous orbits, which, as I said earlier, means they orbit it takes 24 hours for them to orbit. These satellites do a lot of data relay work for NASA's missions, 25 of them in fact, such as the Hubble Space Telescope and the International Space Station. There have been 3 generations of these satellites, with the first being launched in 1983 and subsequently in recent years as well. So these are the components of the space station, and as you can kind of see in that exploded diagram, where each component is on the satellite. So the main component is the bus. This is a kind of general main body for the satellite, which allows them to function properly, essentially. There are also the multiple access antennas, as you can see on the top of the image here. If it's difficult because of the webcam, but these antennas allow for multiple connections and multiple data relay, as the name suggests. There is also the omni antenna, which is kind of cut off, but it is this section here. And this antenna, unlike the others, can actually receive a signal from all around it, which enables it to more easily detect the signals from the missions that it's detecting. Then there's the SGL antenna, which is the Space Ground Link antenna, which, as the name really implies, this antenna is the one which connects the signal between the Earth and NASA's ground-based facilities and the satellite itself, which can then relay information to the missions. Then there are also the east and west antennas, which are these large antennas here on the sides, and these are the main antennas for transmitting signal to and from missions. And finally, there's the North and South solar arrays, which are really quite self-explanatory. These are what power the electrical systems for the craft. Now, as you can also see on the diagram that isn't listed, there's propellant and thrusters. These thrusters aren't enough to propel it very far, because in fact that isn't even their purpose. In fact, these thrusters are meant to direct and reorient the satellite and to make sure that it avoids any space junk so that it isn't damaged. So, I guess that is the end of the main presentation. because this is just a small taster of the many thousands of satellites in orbit around our planet now, and each one of them has an important role in humanity's continued presence in space. And there is absolutely no doubt that there will be more and more satellites launched every year, especially given the rise of the commercial space industry, which will only lead to more satellite developments. Now, now we'll move on to question time. So if you have any questions, just put them into the chat. No questions so far. Well, it seems like there aren't any questions so far. So thank you for participating in this webinar. And if you enjoyed it and want to read more of my content, you can follow this link, which should be in the chat, and I can also post again in the chat in case you want to notice it. So thank you for participating in this webinar, and I hope you enjoyed it.